All right, so in the middle of chapter 8, after we talked about the different types of samples, we have to talk about this concept of sampling error. So it is very unlikely that the mean of a sample will be exactly equal to the mean of the population. And so we define this sampling error as the difference between, and so we're going to go general here, right? We're going to kind of zoom out a little bit. So the difference between a sample statistic and its corresponding population. And then when we're talking about the population, it's not a statistic anymore, it's a parameter. And so an example that we have is talking about the Foxtrot Inn's number of rooms rented in June. And so this is the population, right? And so this is one of those situations where we can actually figure out the mean of the population, which we always represent as mu. And we're told that it's 3.13. Then we are told to take 3 random samples of 5. And taking 3 random samples of 5, we end up finding 3 sample means. Those 3 sample means they all are going to be our x bar. And so we end up with an x bar of 3.80, an x bar of 3.40, and an x bar of 1.80. So when we're talking about our sampling error, we're really just talking about the difference between the true parameter and the sample mean. So for the first one, we're going to end up with a sampling error that's 3.13 minus 3.80, which is what, negative 0.67. We got 3.40 minus 3.80, which is going to give us negative 0.40. And then we have, oh wait, hold on. I'm doing this. I should rearrange this. And then we have 1.80 minus, oh, no. All right, okay. So here's what we're doing. I screwed this one up. Let's just go back a little bit. So this is our mu. This is always going to go first. This is our x bar. It's always going to go second. It's not that hard, Chris. So 3.13 minus now 3.40. And so this is going to give us a negative 0.27. And then 3.13 minus 1.80. This is going to give us a positive 1.33. So we see that the sampling error can be negative, can be positive, can be small, and can be large.